Hello and welcome everyone. So I'll be trying to explain a recent Codeforces round problem number C, constructed problem. Problem's name is that basically constructed problem. And so in this problem, basically, you're going to be given an array A of n non-negative integers, and uh, you are allowed to perform an operation to the array. So let's just talk about the operation here. Uh, only you are allowed to perform the operation only once, exactly once. So what is that operation? The operation is basically pick up any subarray or subsequence, not subsequence, basically sub segments or any subarray, and replace each and every entry or each and every indexes of that particular subarray to another value, any value k, but that should be non-negative. So if I pick this subarray, as you can see, I could take any non-negative integer and replace it with that. So I can. So here the catch is that you can only apply this once, exactly once. Okay, so you can only apply this operation exactly once, but that's the operation. But what am I going to have to do? What sort of output am I going to have to generate? Well, I'm going to have to generate whether the answer is yes or no, and based on what? Based on a condition, which is the MEX. Now, what is the MEX? If I give a short brief about MEX, MEX is basically minimum excluded. What is the minimum excluded of an array? If we're given a task, of what exactly is the minimum excluded of this, let's say this array. Minimum excluded is that the smallest non-negative integer that is not present currently, that the smallest non-negative integer that is not present in this array. So if I talk about this particular array, as you can see, if we just sort it down, then it will be a lot more easier for us to navigate and understand what the output MEX output is going to be. As you can see, 0 is available, 1 is not available. That's interesting. 2 is available, 3 is not available, 4 is not available, and 5 is available. So out of the missing parts, 1, 3, and 4, what is the smallest one? 1 is the smallest one. 1 is the smallest non-negative integer that is not part of the array currently that we're trying to navigate on. And that's basically what the MEX is. So what we're going to have to do is find out, our task would be to literally find out, do some sort of a comparison. After performing the operation, let's say before performing, let's say for the sake of simplicity, before performing this so-called operation, our MEX of the whole array was M, and after you perform that operation, you have to make it such that the MEX of the array is M plus 1. I hope you understand what I'm trying to say. Before operation, if the MEX of the whole array is M, then after the operation, after performing that exact operation exactly once, you have to make it such a way that the MEX of the whole array is M plus 1. And you have to actually output whether you can actually make it or not, whether you can actually come to a conclusion to deal with this constraint or not. So the answer would basically be yes or no, as you can see here. Yes or no. That's going to be the answer. Now, here comes the solution part. How can we actually come up with a solution here? Now, first of all, the bottom line here is we're going to have to somehow make uh, we can actually claim an assumption like that. If we could somehow make our array as such that the MEX is m plus 1, then the answer is yes, otherwise the answer is no. So the first task would be to find out the MEX of the initial array that we're given. Let's take an example, then it will be more obvious for us to understand why would that work. Let's take an example 0, 2, and 0. Okay, let's take 0, 2, and 0. Now, okay, we're given an array. Well, what have we said? Okay, let's try to find out the value m, which is, of course, the MEX of the array before before performing that operation. So, before performing that operation, what would be the MEX from here? 0 is available. Okay, 1 is not available. So, 1 would be the desired m. Now, we need to make this array such a way, we need to transform this array and to apply that operation. What is the best possible way that we can apply the operation such that the MEX gives us m plus 1 in here? In this case, m plus 1, meaning 2, is the only way. What is the only way? The only way is that remove, or should I say, replace every displayed part, every occurrences of the number 2 in the current array that we have. So we're going to try to just replace these values. But the question is, what values should we replace with this m plus 1 that is currently existed in the current array? Because we do not want that if we want to get that m plus 1 value. So if I replace these two with, which value should be replaced with? Of course, it's going to be the previous value, the previous m. So if we just replace that with the previous m, it would be 1, and it would be 1. Now, what sort of operations that we applied here? We applied a subsequence. As you can see, it is a subarray, not a subsequence. So that's very important here. It is not subsequence, it is a subarray. We've applied that operation exactly once, and yeah, there you go. We have an answer. It's yes. Of course it is yes. The MEX is 2, which is m plus 1, basically 1 plus 1. And you have an answer. We have an answer of yes, as you can see. But now we're going to go on to the real solution here, which is basically how do we figure out whether it's actually possible or not. A much more complex example part, if we just take a look at it. Okay, let's talk about this example, which is very important in order to solve this problem. Okay, let's say we're gonna solve the same problem for this array. Okay, basically, well, we're gonna have to find out m. Let's try to find out m. What does m give us? Now, okay, so here, as you can see, okay, 0 is already available. Okay, 1 is not available, smallest non-negative integer, which is the MEX, of course, and let's just put that here. 1, this is my MEX, m, okay, so our target would be to transform, and then our target would be whether there are any occurrences of m plus 1 in the current array. M plus 1 is 2, so I'm going to try to check on whether there are any 2 availables here. Okay, as we can see, we've found out one number of m plus 1, and we have found out another m plus 1. But there's a difference. There's a difference in here compared to the previous example that we talked about. The difference is that they are not related consecutively, so they're far apart from each other. Now, in this sort of situations, what what should you do? First of all, you need to replace every occurrences of m plus 1. So the best way to do that, you cannot just jump right in and take the largest subarray that consists that m plus 1 consecutively. No, you cannot. If you think that, okay, I will replace this 2 with 1, no, it's not going to work because the 2 already exists here. So what you have to do is take the largest subarray that contains all the occurrences of m plus 1 available. So if I talk about here, it would be this from this index till this index. Okay, so what you have to do is pick the subarray. In general, what you have to do is pick the subarray with the first index of the occurrences of m plus 1 and the index of the last occurrences of m plus 1 inside the current array, and replace, of course, the operation itself, every index value, with m itself, which guarantees that we might have a possible outcome, we might have a possible result of final MEX of m plus 1. So I hope you guys understood. I hope all of you have understood by understanding what am I trying to really articulate here. So yeah. So yeah, that's basically what we're gonna do. Okay, let's just do the operation. And also, okay, let's take another example to make you understand. Okay, let's say we have we have an example like that. A 2 is here also. Let's say this is 2, 2. Now you see, if I want to reduce all the occurrences of 2, I will be bounded to take the, I have to take all of these values into account. I don't care about what these are. I have to take into account the first index of the m plus 1 m plus 1 value and the last index of the m plus 1 value, and make this as my subarray. There's no other choice. I have to replace them. So that's the bottom line here. Now, here for this example, if I talk about 3, it would be 1, 1, 1. So basically, I'm replacing all the m plus 1 with the m. And final MEX, of course, that's very important. If the final MEX is not our desired m plus 1, then the answer would be no. We've tried our best. We've come up with the best possible solutions that we can get. And if we, after all of those hard work, if we don't get the perfect answer, the answer would be no. Otherwise, it's going to be yes. As you can see for this thing, for this part, the final MEX, as you can see, it's 0 because 0 is not existed here. But we tried the best possible solutions, and we come up that no, it's not possible, even with the best possible solutions. So what am I going to do? I'm going to say the answer would be no. So that's like the general solution that you're going to do. And yeah, as you can see, it's no here. Now let's take a look at the code part. It's a quite messy code because I have to do it in 15 minutes. Now I guess you would understand what the underlying architecture looks like. Now you're gonna take the array. We're gonna take the array here, and I've actually sorted it for the purpose of finding out the MEX operation. So here is the first MEX. We're trying to find out the first MEX operation, and after that, the first index of the m plus 1 occurrence, as we've talked about, and the last index to find out. And one additional case here is that what if the number m plus 1 does not exist in the existing array? Then what you have to do, you have to take one thing into account here. Then you have to check whether that m plus 1th index is less than or equal to the total length of the array. Because if it's greater than the length, then the MEX would never give us the value more than n plus 1, value more than n. So that's exactly that's the additional extra case that you need to take care of. If it's more than if it has to be less than or equal to n overall if the value does not exist initially, uh, the n plus one of value in the current array. So that's like the extra case that you need to handle. And but apart from that, that's the general part. And that's the aftermath MEX part. And that's going to give us the, and after, trying out the best possible solutions, I'm going to try to check whether that's equal to the uh, m plus 1 at whether that MEX is m plus 1 at MEX or not. So if it's equal, then it's going to be yes, otherwise it's going to be simply no. So yeah, I hope you guys have understood. And yeah, till next time, goodbye.